Okay, hello everyone. This is video for the task A of lab 6. I have released the lab 6. So what you need to do is that first you need to set up the lab hardware as shown in this picture. So this is straightforward. You are actually connecting 10 LEDs at from pin 0 to pin 9 of the Arduino board. So which is equal to like connecting first 8 LEDs on pin 0 to pin 7 of the port D, and then the last two LEDs are connected at pin 0 and pin 1 of the port B. Other than that, you have this potentiometer, which is a three-leg device. So the left and the right device, any one of them you can connect with the ground, and the other one with the power supply, as I have shown here that I have connected one with the ground using black color wire and the other one with the power supply using the red color. The middle leg of the potentiometer is connected with the A0 pin on the Arduino board, which is analog input or ADC input, zero input of the AVR microcontroller. So before proceeding, I would encourage you to go and read these two links. So first one is a very small reading about what is a potentiometer and how it works, and second is how to connect a potentiometer on the breadboard. It is a YouTube video only 2.5 minutes long, I guess. So after making all the connections, what you need to do is that you need to write following pseudocode in the assembly form. So in that pseudocode, you first need to configure port B and D as output ports. Then you need to disable digital input buffers on ADC pins, just like we have seen how to do it in today's lecture. Then you need to write the value in ADMUX register so that you select ADC0 as the analog input, you select AVCC as VREF, a reference voltage, and you describe or you set that 10-bit output should be write adjusted. Then you need to write value in ADCSRA register to enable the ADC, set the prescaler, clock prescaler to 1 over 128, and specify that you want to use the polling mode and you don't want to use the interrupt mode. So you need to make the interrupt bit ADIE 0. After that, you enter in an infinite loop where you first start the conversion of the analog input to digital form. Then you wait until the conversion is completed, and once the conversion is completed, you read the 10 bit digital value from ADCL and ADCH register and send the value to the LEDs, and then you reset the ADIF to 0 set so that you can start reading the next analog input. So in task A, what you need to do is that simply you need to download these two files and then put them in a new sketch named Lab6 Tasks A. And then you need to connect your hardware as shown in the figure above. Then simply compile and upload the program to your AVR microcontroller. And upon running or uploading the program, if all the LEDs are switched on, then you are done with the task A. So the purpose of task A is just to make sure that all the LEDs are working and give you some confidence. This task carries no points, but it is mandatory. You must show to TA that all the LEDs are switched on. Uh, yeah, this is a typo. I will fix it. So you must show to TS that all the LEDs are switched on before proceeding to the next task. Okay, so let me show you. I have actually already downloaded those files, so I have made no changes. These are exactly the same files. So I'm compiling them first. So yes, compilation is successful, and I have already connected my board. So I am now uploading the code, and now I can show you that all the LEDs are, you can see here that all the 8 LEDs are 10 LEDs are switched on, right? So I am like now confident there is no problem, at least in switching on the LEDs before I move to the next task B. So that's it, what you need to do for the task A in the lab.